The project is called ACSAGO, which is short for Active Control Side Stick for Aircraft Ground Operations. During taxiing, so while moving the aircraft on the ground, pilots currently use multiple controls. In our project, we're trying to replace all of these controls with a single control, which is an active side stick. And this can be used to control both the speed and also the direction of the aircraft. The benefits of this technology are multiple. There's first of all the benefits to the pilots because the proposed technology will reduce the workload of the pilots, especially because this technology allows the pilots to set a particular speed for the aircraft, which is similar to the way cruise control works in cars. There is also a secondary benefit in terms of safety because the proposed technology will not allow the aircraft to exceed particular speed limits. And also, if the aircraft deviates from the taxiway center line, then the pilots will be notified and they will receive force feedback on the side stick. And the third benefit is economic because with the help of this active side stick, the tiller, which is currently present on large commercial aircraft, becomes redundant. The project consortium consists of two main partners. There is the University of Malta through the Institute of Aerospace Technologies, which led the project. And then the other partner was Quero Limited. This is a local consultancy company which consists of a number of airline pilots.
Quero initially was involved in the requirements capture in the project. This involves looking at how the pilot normally operates during the taxi operation in this case, seeing what the pilot does during taxi, and then identifying how to translate these into a way where the new technology could enhance how to do these tasks. Then after that, I was involved a lot in the testing phase where we trialed it many times. We went through various iterations of checking the way the software would work. And after we had smoothed it out all the kinks to a certain point, we brought on another pilot from within Quero who was not involved, so he was not biased. And we let him have a go at it as well. And we got further input to allow us to further refine ultimately so that we would be ready for the evaluation phase.
As one of the pilots who helped test out the active side stick technology, I found it to be an interesting proposition because it allows a different way, a more efficient way of taxiing the aircraft before takeoff and after landing. At the moment, when we taxi, we're basically using the rudder pedals, using the thrust levers, and also using the nose wheel tiller. So that is three things that we're doing sometimes concurrently or in sequence. With this technology, it offers the opportunity to have them all located on one control stick. So in that way, you could get better focus on just doing one thing, and it would relieve your attention from other things and maybe focus more on maybe keeping a visual lookout or monitoring one's charts.
MATLAB was used as the main platform in order to develop our control algorithms. Then, in order to test out our control algorithms, we use Explain as the main simulator to test out the algorithms developed. And finally, pilots were brought in so that they can assess the algorithm itself, whether it makes sense in the real world or not.
The project was funded by the Fusion Technology Development Program of the Malta Council for Science and Technology, and the total value of the project was approximately 200,000 euros. And this funding was important for us because it allowed us to purchase the active side stick, which we use for this project, and also to employ researchers to work with us to conduct the research.